like you guys, we stumbled upon this super intriguing problem, and it was so intriguing that me and a colleague couldn't let it go and tried to solve this puzzle. And I think we have solved it and found also a nice way to graphically represent the solution to this problem. And it is such that I don't think it's a spoiler for anyone who's still trying to puzzle and solve it for themselves. But I think that maybe someone who has solved it might appreciate the graphical representation of our solution. So as suggested in the original puzzle, we have solved it using the conservation of energy. Here the conservation of energy is represented by the circle. The radius here is basically the total amount of energy in the system, and it cannot change. On the axes, it has something to do with the velocity. So on the y-axis it's something to do with the velocity of the left mass here, and velocity of the right mass is on the x-axis. And the thing is that well, for example, in this position here there is velocity, initial velocity of the right mass, but there is zero velocity of the left mass. And the last bounce happens when this position of the ball, or this position in this graph, ends up in this gray zone here. And the second thing is that we see a collision as a mirroring around a particular axis. So if two objects collide together here, we mirror around the red axis, and if the red ball interacts with the wall, it's simply a swapping of velocity, or in other words, a mirroring around the horizontal axis. Then this angle between the red line and the positive y-axis, or the slope, depends on the mass distribution. Okay, so what happens when we have equal mass distribution? We have indeed 3 bounces and 3 times a mirroring around the axis. Here we set the mass to a mass ratio to 100, and so this area where you need to be in for the last bounce is smaller, and you will also see that it influences the way the collisions occur. So here we have the first mirroring around the red axis, black axis, red axis, etc., 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 until we have arrived in that gray zone where we had the last bounce. Right there. Cool.